Hello everyone. Today let's start with a new name reaction, that is a Appel's reaction. Okay. Now the general reaction of the Appel's reaction is, in this the alcohol in presence of carbon tetrahalide and triphenylphosphine, it gets converted into the alkyl halide. The most simplest general reaction of Appel reaction is this. Okay. Now in this reaction, the hint how to remember Appel's reaction is that this reaction gives 100% inversion product. This reaction gives 100% inversion product. Meaning, if we have a reactant like this, for example, we have, let's take this example, we have like this. Okay, this is dash and this is wedge. Wedge means in front and dash means in the back side. Here we attach H and here we attach OH. Again we react this with carbon tetrahalide and triphenylphosphine. Okay, 100% inversion, that means the product will be opposite of what we have in the reactant. That is, on dash we will have halide and on the wedge we will have our hydrogen. Okay, a very simple reaction and very simple to remember. Okay, just remember that it gives 100% inversion. Now let's see in detail about its mechanism. Okay, the very first step that happens in this mechanism is that halogenation of triphenylphosphine. We have two reagents, that is carbon tetrahalide and triphenylphosphine. So first is halogenation of triphenylphosphine. Phosphorus have lone pair and this will take one of the halide. It will form positive because it's giving its lone pair and taking halide and 3 phenyl ring attached to this, right? And we are left with what? We are left with carbon and 3 halide groups attached to the carbon. Okay, this bears the negative charge, right? Then we have alcohol. And this carbon negative will take the positive, will take the H positive and will form CHX3 group, and we are left with the alkoxide. Now whenever R that is attached to oxygen and oxygen that is attached to H, oxygen being more electronegative will have negative charge, hydrogen being less electronegative will have positive charge. That means while leaving we are left with the alkoxide group, right? In the next step, what happens is that this phosphorus, the bond between the phosphorus and halide breaks. Okay, the bond between the phosphorus and halide breaks. Halide takes the electron, leaving the positive charge on the phosphorus, and this attacks on the alkoxide. Okay, and there is a formation of this bond. And there is a formation of this bond, that is phosphorus and oxygen attached to the alkyl group. Okay, oxygen have two lone pair. This lone pair, it will donate to the phosphorus and this will form P double bond O. Breaking this bond, okay, and forming R positive. Now this is a driving force. The formation of P double bond O is the lone driving force of this reaction. This is a strong bond. P double bond O is a strong bond and a driving force of this whole reaction. Because of the formation of this bond, this reaction is taking place and leaving us with the alkyl halide group. right? We'll get this product. Okay, so in simple, this was the mechanism of Appel's reaction, and in which P double bond O is a strong bond and is also a driving force of this whole reaction, and it gives 100% inversion product. For example, we'll do one example. Okay, we have OAC group attached here, we have OBN group attached here, and we have OBN group attached here, and OBN attached here, okay, and OH attached here. Okay, now the key points that I have told you to remember are we have our reagents, right? We have our reagents here. It is kept for 24 hours and 96%. Okay, I told you the key points how to remember the Appel's reaction, that is, it gives you 100% inversion. Okay, and the formation of P double bond O is a driving force of Appel's reaction. So we'll get the product. Rest, keep everything same. Do not touch this group. Rest, keep everything same. Okay. And getting, only focus on 100% inversion. Here the OH is on the equatorial position, right? But we need, or we get 100% inversion there. So the halide group, or here the halide is Br. So the halide group or the Br group will attach from down, and hence we get a product. Okay, so such is a simple Appel's reaction.